Shared it with other people. Have the link to it?
Yes, they do.
Okay, so
They've been sent.
So I think this is the number.
5 people have come on.
Yeah.
But can you see who they are?
Try clicking on that.
Clicking on the people.
Which one?
People 7 have
no.
joined. No, you can't.
Is it lower on the?
So let's see.
Where try. Okay, hit not. Close this. Hit not now.
Okay.
Okay.
Gayatri, Nandan. Hello, Nandan.
So so there's the chat, the text chat.
Okay. Randeep is there. Ramesh. Can you lower the camera a little? All right. This way. Ramesh, is that it?
Okay. Yeah. Can you hear us?
Oh, hi, Prahlad.
Hi.
Yeah, okay, Ramesh can hear.
Okay.
Could someone say something so we know that we can hear you? You can't hear.
Right.
All they
can do is type.
All they can do is, okay.
Yeah.
All right.
Okay.
Okay, great.
So, start typing your questions.
Okay. Okay, good. We can
keep the LTs open on my computer.
Are you going to type a question to John?
I'm just going to I'm going to get the LTs up. So
all right. Okay. Okay, good.
It's useful.
Yeah. What are your questions? Okay.
Nanda, need to understand justified concepts better. Okay.
Okay. Justified concepts means concept in this in the context of inquiry. Concepts that need to be part of the academic vocabulary. So something like red versus blue, it's useful distinction, but it's not clear that it's useful for academia. It's part of our everyday life. In contrast, something like force, field, gravity, atom, nucleus, etc., are part of the academic vocabulary, and we have to demonstrate that they ought to be part of the academic vocabulary by saying they can explain something that cannot be explained without these concepts. So something like insect is a legitimate category because that allows you to state generalizations and state correlations and so on. So that's what it means to say justified concepts. Is that clear?
Perhaps not quite.
Okay. You try.
If you take a word, can you have a word like B? Just write this and see if you have a BTS. Does that form a word?
Not a short form, but a regular word.
Short form, a regular word that you can pronounce. If you can't do that, why is it that you can't? Now, if you put an I between B and T, right? Bit, then you can say it, bits. Oh, what is the kind of thing that you have to have in a word? Something like I, right? And when you learn your ABCD, you say A, E, I, O, U, right? And you call them vowels. Now, they become justified, a vowel becomes a justified concept because you have to, it allows you to make a statement like every word has to have a vowel. Okay? Now, we're not talking, when we say vowel, we're not talking just about the letters A, E, I, O, U, but something that is pronounced like a vowel. So sometimes you get Y as in my, right? But because you need that notion vowel, the concept vowel, to say every word, in order to be pronounced, has to have a vowel sound in it. And vowel becomes a justified concept. Nandan, does that make sense? I hope so. Okay, if it doesn't, we'll come back to it. Let us know, or we'll go on to the next question. All right. So we have Gayatri had sent us some questions, emailed us questions beforehand.
Mm-hmm. Can you read the question?
I'll read the question. Mm. In activity 2, the weight and math performance discussion, suppose the study controls for same age, geography, and there is a correlation. How can we disprove causation? Does disproving causation require an experimental study? Or can we just say that there may be alternative causal factors?
Yeah, I think for causal explanations, there is always alternative causes. So suppose there is indeed a correlation between weight and mathematical performance for the same age group, then you could look for causes in whatever it is that, for example, the genes that increase weight may also be increasing mathematical aptitude. Of course, I think it is unlikely, but that is still not a possibility that can be ruled out. Or some indirect connection, some other cause, whether it is genetic or not, some other cause that causes both. For example, it could be the case that the socioeconomic background of the children could make a difference to both mathematical abilities and to weight. So, like kids who have enough to eat will also have better mathematical aptitude because they belong to a certain socioeconomic class. And the poorer kids, because they go hungry, they have less weight, and maybe they don't have time to study and time to devote to mathematics. That could be the cause. So there are other causes that we ought to rule out. And it's only when you can show that this is a causal factor. Either this is the causal factor or a causal factor that you can establish causation. So in sum, causal explanations always need to be careful about alternative causal explanations, unlike correlation.
Okay. Gayatri, you're also asking, is justified concept same as natural class? Yes.
Yes.
The entities, when you have a concept, the instantiations of that concept form a natural class. Yes. So it's when they form a natural class that you say that the concept is justified.
Yeah. All categories or all classes are concepts, but not necessarily. It is not the case that all concepts are category concepts. So gravity, for example, is a concept. It is not a category. In contrast, vertebrate is a category which is a concept. So a justified concept is necessarily a natural class.
Actually, another term to use would be a justified category.
Justified category, justified concept.
Would be the same as natural class. Okay, Gayatri has another question on email.
What's that?
Say, if we put a pencil, a spoon, a rose, a biscuit, and a stone in a basket, we have a set of things in the basket, but they don't form a category. But don't they form a category called objects, non-living things? Is this valid?
Yeah, but then that will include that. If that category consists of only pencil, spoon, rose, biscuit, and stone, and basket, and stone, and nothing else, if it doesn't include, for example, table or cup, then it's not a category, because the category called object or category called inanimate things will include many more.
So let me try and put that slightly differently. Do these things, pencil, spoon, rose, biscuit, and stone in the basket, form a group that has some property that defines all and only the entities in that basket? That's not the case, right? So if you say non-living, a whole lot of other things outside, same with objects, and therefore they don't form a category. Does that make sense?
While Gayatri is thinking about that, shall we respond to her third?
And then, Prahlad, difference between the lion is a noble animal and lions are noble animals. Okay. Yeah. Want to go?
Well, the lion is a noble animal. We are not typically thinking about a number of lions. We are thinking about whatever it is that the prototypical lion.
Anything that qualifies as lion.
Right. So it's not, you're not thinking about it as members of a category. When you say, but on the other hand, when you say lions are noble animals, what you're saying is that members of the category lion, all of them, each of them is a noble animal. So it's a slightly different conceptualization.
At some level, the meaning might be the same.
Yeah.
But the way you think about it, in one case, you're making a statement about the whole the category. In the other case, you're talking about every member of that category.
Yeah.
Okay.
So there is the other question that Gayatri is asking about supra category.
Yeah.
Supra category is simply the mother category. So let us say human species is a category. Primate is a supra category because primate is a higher category, the mother category of humans. And then if you say, let's say, mammals, that primates come under mammals, so mammals is a supra category. Vertebrate is still higher, and so on.
Another way of thinking about it is you have subcategories. A category has daughters, many groups under it. Is there a group of which the category is a part, is one of the subcategories? Then that mother is the supra category. Yeah. Right?
Sub and supra, mother and daughter. Sorry, the other way around.
So the grandmother category.
Yeah.
Let's say.
So who are the 11
Thinking
people?
time.
Yeah.
Thinking time.
Mm.
Can I have a piece of paper for that? Do you need that?
No.
All right. Ready?
Okay, guys, so what next? We are not going to raise questions. If you have questions, then.
Could you just go there? In case we've missed something. No, go up. Up. Okay, we have it. All right. Down. It's all the way down. There. There. These three theorems must be admitted as knowledge that the concept of triangle is crucial for these propositions. We must accept triangle as a justified concept. Okay. Yeah.
For a concept to be justified, we need to show that it is necessary in the propositions of knowledge.
The statements, the generalizations that we make, when we make them, if we have to use that concept, then if we can't make that statement adequately without the concept, then we say that it's crucial in that statement. Now, there are several statements like that, several propositions in which that concept occurs, and we cannot make those statements without that concept, then we have to accept that that concept is a justified concept. So in this case, it's triangle. We are making statements, we're making generalizations or about triangles, and they cannot be made without the concept of triangle, and therefore we say that we have to accept triangle so the notion of triangle is a natural class. It is a justified concept.
So take something like polygon. There are many theorems on polygon, and if these theorems are part of our knowledge, we admit them as part of our knowledge, then we should also accept polygon as a justified concept, or polygon is also part of our knowledge, therefore it's a justified concept. And the justification is that the concept of polygon is necessary for the statement of a number of theorems. And you could also say that the concept of convex polygons, there are many theorems about that. But if one of the angles of a polygon is concave, and suppose you say concave polygon, is that a justified concept? Are there any theorems on concave polygons? Likewise, right angle triangle, there is a theorem, Pythagoras theorem. There are other theorems about right angle triangle. But what about triangle with 35 degrees? One of the angles is 35 degrees. Are there any theorems on that? If you can't find any theorems, then that concept of triangle with 35 degrees is not justified. Triangle in which all angles are equal, equiangular triangle, that's a justified concept because there are many theorems on that. But you could think of triangle in which one of the sides is 1/3 of another side. That's not a justified concept because I can't think of any. Okay, stop. I can't read what you're looking. Oh. That is
the difference between approaches in mathematical and scientific inquiry. Seem to understand the given examples, but then not having enough. Gayatri, I think this is something that you need to wait a little.
Will everybody see this question?
Does
read the question.
Okay.
Yeah.
The question is, can you talk about differences between approaches in mathematical and scientific inquiry? I seem to understand the given examples, but then not having enough clarity so as to attempt one. I think that's going to come slowly. You need more practice in that over the next perhaps couple of LTs. It's something that has to come slowly. We can't, it's not going to make sense to, you can see others' questions. Sorry. Go ahead.
We are going to devote some videos and some discussions. Some videos will be devoted to scientific and mathematical inquiry.
Yes. And actually the next 2 LTs are on mathematical inquiry.
Yeah.
And hopefully that will clarify things.
Yeah. Nandan's question, legitimate non-arbitrary categories, the same as natural categories.
Natural class,
Yeah.
justified category. These are all...
A concept that has a place in academic inquiry. That's what it means.
It's all different ways of saying the same thing. Non-arbitrary, legitimate category, justified category, natural class.
So maybe take this example in classification of life. They have these different hierarchies called family, order, phylum, and so on.
Kingdom.
Now, kingdom, yeah. Do these things ever figure in any generalization, observational generalization, or in any theoretical statement? If the answer is no, then these are not.
Then they are arbitrary. They are not non-arbitrary.
Yeah. Somebody just invented these words with no obvious use other than getting children to memorize them. So these, Prandeep was one who couldn't attend any of the.
Yeah, and I don't know if he is on the live.
He's there. I mean,
is he there?
Yeah, there.
Where do you?
Here.
Yes, yes.
He said hello, but after that he hasn't. So Prandeep, you couldn't attend either Chennai or Pune face to face. What are your questions? Okay, looks like there are no more questions.
Well, give another 5 minutes.
Another 5 minutes? Yeah, okay, fine.
By the way, thank you, Gayatri, for sending those questions yesterday.
Yeah.
Because that actually helps.
Yeah.
The first thing I guess we have to do there is to become serious.
Sorry, you're talking about Prandeep's question?
Yeah, I'm talking about Prandeep's. Earlier, Gayatri had said that we can see others' questions, so I'm assuming that. Prandeep, the first thing is to become inquirers ourselves, and it's only then that we can bring it to somebody.
Yeah.
How do you have them imbibe the spirit? It's something that if you start very early, say in kindergarten or at least in first grade, then you don't have to do very much about it. If it's later on, then you have a certain habit of mind and mindset has set in, and it's very change that.
Yeah.
So the only way is for it to be built up bit by bit, and for students to be shown a different way of doing things.
So it's kind of like classical music.
Yeah.
If you want to imbibe classical music, if they live in an environment of classical music where lots of people sing or play, instruments, then they will imbibe it. But at an older age, like when they become teenagers, they will have to be explicitly taught some of the elements of classical music. And we are trying to do that kind of explicit teaching rather than absorbing through osmosis from a community. It's like a culture. The culture of inquiry is imbibed from the people around you. Can Prahlad
Can generalization be understood in terms of a categorization?
Not necessarily. Some generalizations are based
No,
on
no, I don't quite understand the question, Prahlad. Do you mean, are generalizations a form of categorization? Is that what you're
I see.
asking?
Okay.
Or do generalizations have to be stated in terms of categories?
Or do generalizations always require categories?
Right. Actually, the forming of categories itself is generalized, a certain kind of generalizing. When you find things that share a property and you say that it's a category and it's a legitimate category, then it is a generalization. Okay.
Not necessarily.
Yeah, not always.
Yeah,
not always.
Because you can have a generalization on the relation between radius and circumference of a circle. Circle is a category.
Radius is a category.
Radius is not a category. It's an entity. It's a concept.
It's an entity.
So is circumference. But you can also state relations between things without categories. So, for instance, you could say about two things. So there is a correlation between we have to assume a population in human beings is a category. There is a correlation between height and weight. Height and weight are traits. So you're stating a relation between two variables, but of course you need to specify the scope of that relation. It may not apply, for example, to tables, or it may not apply to balloons and so on. It applies to humans. So the category will come in only as the kind of specification of the scope. Other than that, categories, in many generalizations, categories may not be needed.
Yeah, it's so it could be a generalization could be the statement of a category, or it could be the statement of a relation between two categories. Okay.
This wouldn't apply to a set theoretic statement where everything is a member, but that's the matter now.
Yeah.
Well, it's not clear what approach. I would say, Pradeep, that the questions about teaching inquiry to children should be reserved for, let's say, at least towards the end of the course, if not after the course.
After the course, yes.
Yeah. This is like asking somebody who has not had the experience of, let's say, watercolor painting, or any painting for that matter, asking, how do I teach watercolor painting to children? The first step is to learn watercolor painting. So this is the kind of question that can be discussed only by the end of the course.
After the course.
Yeah, after is better.
Yeah.
General beliefs about the world need not be only about observation generalizations. So suppose I were to say that the world was created by an omnipotent God. That's a belief about the world, but that's not an observation generalization.
Yeah, and also an observation generalization in this context, in our context, has to be sort of established, whereas our beliefs are, sometimes we don't even know we have that belief, that it's not, and it may not be a generalization, it could be based on just one particular example. Yeah. An article of faith. That would be the best way to put it, I guess.
So scientists have this belief that the world is governed by principles which are logically not contradictory. That's an article of faith that science is based on. Things of that kind.
Actually, a good example to take might be beliefs about the world. Take a child's belief about the world, about people in the world. The belief that everyone likes me, and therefore my behavior towards them is reflected in that. Or another child who feels, for whatever reason, nobody likes me, and that child's behavior reflects that. These are beliefs about the world, and in some sense they are generalizations, but they don't have to be observational generalizations.
So there are people who believe that after the death of the physical body, your soul continues to exist, and that soul becomes acquires another body. That's called reincarnation, rebirth. Now, these are not observation generalizations. These are simply articles of faith. It's not clear that any of them can be justified or even refuted. Some of these.
So another, actually, you're asking for examples of theoretical categories, right? Well,
something like noun and verb is as far as linguists are concerned, these are theoretical categories.
Right.
They're not observable.
We think that we know what a noun is and what a verb is, but if we start exploring, we discover that we don't have definitions for those, and they have to be based on a huge number of observational generalizations that require these as theoretical categories to justify them. So those would be, noun and verb would be theoretical categories.
We should someday produce a video, nouns, verbs, adjectives, etc., being theoretical categories. That must be fun.
Yes.
Welcome. Looks like the questions have been exhausted.
Madhu is in Delhi, and this is we are in Pune.
Yeah. The voice that you hear without the body is Tara's.
Where do exceptions to rule fit into? Scientists don't like exceptions.
Yeah. So those are actually counter-examples which show that the rule is wrong.
Otherwise they're not interesting.
Yeah. So if supposing I said that...
Just a minute. When we're talking about generalization and categories, I mean. Yeah.
Take something like all metals are solid when in temperature. Now, mercury, obviously, if mercury is a metal, then obviously that's a counterexample. You shouldn't treat it as an exception.
Which just means that generalization is wrong.
Yeah. Then, likewise, for example, everything expands when heated. Well, by and large, it is true, but if it is water or ice,
Ice does.
No.
When it's cold, it
expands. Water at 4 degrees, expands. If it is heated, it doesn't expand; it contracts. It contracts either way. So these are not exceptions; they are counterexamples to the rule. An example that shows that the rule is wrong or the generalization is wrong. Let me give you another example. If I were to say that every adult being has 10 fingers, exactly 10 fingers, then people with 11 fingers will not be exception, they will be counterexamples, will show that the formulation is wrong. So we should say, at best, most human beings have 10 fingers. That should be okay. Or you can even say almost all human beings, or you can say 99% of human beings. So change the rule when you find a counterexample.
Counterexamples to show incorrect generalizations. Sorry, can I just? Yeah. Means most of the definitions need to be rethought.
Yeah.
Absolutely, yes.
Yeah.
Yes.
Yeah.
So exactly like the definition of solid and liquid.
That's right. It's obviously
Practically,
wrong.
yeah. Whether they have to be modified or not, they certainly need to be rethought from this perspective of counterexamples. Yes.
Our favorite example is species. Just about every definition seems to have counterexamples. How does categorization help an inquiry? Well, as we explained earlier, categories are needed to state generalizations, to state general propositions. And if those general propositions are needed, the categories are also needed. Without the category vertebrates, for example, you can't state any of the generalizations on vertebrates. That vertebrates have lungs, vertebrates have such and such properties. Vertebrates have a food tube, and so on and so on.
So when you're inquiring, you are trying to understand, we're trying to understand the world around us, the world within us, the imaginary world of mathematics, and so on. And in order to understand that, these worlds, we need to form generalizations. Those generalizations have to be made on categories. And therefore, category is relevant for, crucial for inquiry.
So let's take some strange examples like fairy and devil. Do we need these categories to explain anything? As far as I know, no. Nothing is explained by these concepts. So you don't need these categories in science or in any other form of academia, for that matter.
No, that's not. We don't need it in academia.
Yeah.
But in imagined fantasy worlds.
Fantasies, yes.
But then for that, if you want to tell someone what you mean by an elf, for example, you have to give a definition. And in that, in giving or at least a description, and in giving a description, you're actually forming a category of creatures that fit into that description. And therefore, that's a category. Yeah? Okay. If definitions are to be rethought of, how could we convince elementary, secondary, senior students what is to be accepted to pass off? At this point, I don't think, again, you should go into that. I think in order to teach students or get students to look for definitions that are justified, we have to be able to justify definitions ourselves, right? And so anything to do with teaching, perhaps you should set aside. Yeah. Teaching via the inquiry mode, you should probably set aside till after this course.
As for exams,
yeah,
the concepts which are asked for exams are not necessarily justified. You simply tell the examiner whatever they want to hear. Nothing else is needed. That's a separate issue. Okay.
This is wrong with the way.
Categorization is taught in schools. What should we say?
Do you learn categorization in school?
You don't learn categorization. You learn names of some categories with that textbook thing.
Yeah.
Correct. That's all.
So, do you ever ask the question, why do we need this category? What is this category? What does it relate to? What are the generalizations that we need to uncover about this category? No, right? So,
so you're simply told, for example, there is a distinction between metals and non-metals. I don't think any textbook discusses why we need the notion metal. We read about different category.
We need in science, math.
Can you explain that? I don't understand, Nandan.
Yeah, Nandan, you read about the different categories in science, maths.
Or do you mean the different categories called science versus math? Is that what you mean?
Why do we need the notion of metals? Aha. That's a whole inquiry question.
This was a question we raised for you to think about. We are not going to answer that question.
See if you can make general statements about things that you want to class as metals and properties that only metals have, non-metals don't. The definitions we learn in 5 years are often intuitive, like a small child will quickly sort shapes.
Yeah.
But when we do high-level math, we are contemplating on what is appropriate definition for a triangle.
Yeah. Children, very young children can learn.
Yeah. How do you see these intuitive generalizations versus definitions? Actually, do you really, even later on at high levels, do you you might describe triangles, for example, but do you really justify them?
Not in regular courses.
Right. So those definitions are given to you. generalizations come from within, unless the child is told that this is what X means. Other than that, there really is no difference, right?
There is no difference in the actual textbooks or the courses that we've learned. Yeah.
Not that I have seen.
Yeah. They simply assert the categories, they don't justify them.
Actually, if we could take children's intuitive generalizations and build on them and have them come up with, have them find reasons for those intuitive generalizations or help them modify those generalizations such that they become definitions, that would be extremely useful. But that doesn't happen overnight. It's a long path.
And also justify those concepts. The individual intuitive classes may not all of them need be justified.
They may not be justified, but we don't tell the child that they're not justified. We guide children to, with examples or whatever, to find their way through modifying, refining their intuitions.
Okay.
Yeah.
All right. So the next time we have a meeting,
let's
we'll
just
do it on a day when there's no quiz.
Yeah, one quick check. Any more questions, or are we ready to pack up?
Okay.
Okay.
Okay, folks.
Okay. Thank you.
Yeah. Bye.
Thanks.
Bye. Yeah.
Bye. See you next time.